This is Take 5 with Bentley, Nevada. And again with us today is Chris McMillan, Senior Product Manager for Bentley, Nevada's sensor portfolio, and that includes the Ranger Pro wireless system. Been having a fascinating discussion with Chris, and we've been doing a pretty thorough tour of the Ranger Pro system. Chris, welcome back. It's good to have you.
Good to be back.
In the last installment, Chris, we talked a bit about whether customers were going to need a portable data collector, and essentially the answer was you're always going to have a need for a data collector because some of your assets, you're not going to want to monitor them permanently. You can't justify it. But on those assets that have the wireless system, in most cases, there's going to be a rich enough data set coming back wirelessly that you're not going to have to use your data collector to augment that data on a regular basis. Did I get that pretty well correctly?
Yeah, no, you really did. Ranger Pro offers, again, quite a highly configurable settings, of course, coming through in a great variety of depending on what the application or what the operator may wish to be looking at. Everything, obviously, from your typical SI units to your English units. I think what you're talking about here from a rich dynamic set, basically, does it have enough sampling frequency, if you will, or lines of resolution, as some like to call it, in order to provide a rich enough data set to make a determination? The answer is absolutely. I mean, you can configure a number of samples. If you're looking at an accel waveform, et cetera, all the way up to 8192. That's quite a few number of samples. And then a traditional velocity spectrum. Obviously, the higher number of lines of resolution, the greater you can be able to troubleshoot. And again, Ranger Pro has a wide variety of range depending on what meets your needs, but all the way up to 3,200 lines coming through. So again, there's quite a bit of flexibility coming through and embedded in the Ranger Pro sensor, including what we call peak demon, which is basically an accel enveloping technique here to help you ascertain what's going on.
Well, Chris, I think that's going to put some of our listeners at ease. I mean, the typical asset that is a candidate for wireless sensing usually has rolling element bearings in it. And of course, the diagnostic techniques for those kinds of bearings generally has to do with the geometry of the bearing and the frequencies it generates based on that. And so you're spending a lot of time looking at spectral type data. And with 3,200 lines, it sounds like Ranger Pro can deliver the goods, so to speak. What about, you mentioned acceleration enveloping. What about customers that prefer to look at things in RMS units rather than peak and some of the other kind of signal
Certainly.
processing aspects that they might need and want?
Certainly. Again, Ranger Pro offers that flexibility depending upon, what the user, what your condition monitoring program may call for, or what your level of comfort in, whether it's traditional peak units or if it's traditional RMS units. You can look at either case here.
And you mentioned acceleration enveloping and peak demod. Are they kind of the same name for the same idea, or are they distinctly different technologies?
I mean, peak demod, that's a pretty well-known methodology used out in the industry today, certainly in the condition monitoring world. So we leverage that as well. You can certainly, as you're taking a look at a data, do a couple other manipulations within System 1, depending on how you wish to look at it.
And as you mentioned in one of the earliest episodes in this kind of lengthy conversation we've had, multi-part conversation, the Ranger Pro is able to actually return data from 3 different axes, X, Y, and Z. So it's a triaxial accelerometer embedded in that sensor, and also temperature at the same time, correct?
That is correct. So these are all time synchronized. So of course you can help troubleshoot what could be going on with that particular machine or bearing in this case.
Okay. And excluding the temperature measurement, of course, the X, Y, and Z axis, do you have roughly the same set of tools for each axis in terms of, spectral analysis and so forth?
Spectral analysis, yes, of course, very similar across the X, Y, and Z. The only exception would be the most dominant axis in this particular case. If the sensor was vertical, that's the Z axis. It kind of follows the right-hand rule, if you will. That's where the peak DMOD value would come because, of course, that is the most dominant axis. So peak
Yeah.
DMOD is available on Z-axis only.
Yeah, well, that would make sense though, because typically the whole application of that is for the bearing frequencies, and they're going to get transmitted along that z-axis. Well,
Right.
Chris, thank you. This has, as always, sound like a broken record, but very insightful. Well, thank you. You have been listening to Take 5 with Bentley, Nevada.